Hi. Hi, my dear students. Today I have prepared one video. Its content is cube roots of unity, nth roots of unity and their properties. Cube roots of unity and nth roots of unity and their properties. On its application, some questions for your better understanding. Next, DEMOIVRE's theorem. DEMOIVRE's theorem result and its properties and some applications on it. DEMOIVRE's theorem proof is not necessary. It is not important. Even in intermediate exam also it will not be given. So, the result of the DEMOIVRE's theorem is very important. The application is very important. So, DEMOIVRE's theorem result, its properties and its application has been discussed in this video. Next, geometrical representation of the complex number. Just I introduced for you. By Gauss, the great mathematician, geometrical interpretation or representation of the complex number by Gauss, the great mathematician, has been discussed. So, that was with vector notion. So, you learned somewhere in physics or somewhere vectors. So, here also vector notion is introduced or involved in it, and polar coordinate system also involved in it. So, the vector system and polar coordinate system both are in the application of the complex number. It was introduced by Gauss, the great mathematician, and their properties and some applications have been discussed in this video. Please, without wasting time, go through the video immediately. My dear students, today let us learn geometrical representation of addition and subtraction of complex numbers. Gauss, the great mathematician, first thought that complex numbers can be represented on a two-dimensional plane, which is therefore called complex plane or Z plane or organed plane. In this complex plane, any point other than origin denotes a vector. You see, in organed plane, any point denotes a vector. Firstly, this was introduced by Gauss. See the figure first. This line is x-axis in Cartesian system. But in the presentation of the complex number, we have to call this a real axis. It is not x-axis, real axis. It is not y-axis, imaginary axis. It is not y-axis, it is imaginary axis. Real parts can be presented on this. That is why it is called real axis. Imaginary parts can be presented on this. That is why it is called imaginary axis. I am going to see the figure. Here, this is P1 of Z1, this is R of Z, this is P2 of Z2. Here, P1 of Z1 I have taken. Okay. Here, P2 of Z2. Here, what is this? R of Z. You have seen in vector system, vector algebra, this R of Z equals to, this OR bar equals to OP1 bar plus OP2 bar. That is in vectors. The resultant vector equals to OP1 bar plus OP2 bar. And this is a parallelogram law in vector system. You see how it is. Vector thought. So in complex numbers also vector thought will be there. OP1 plus OP1 bar plus P1R bar equals to OR bar. Triangle law in vector system. OP1 bar plus P1R bar equals to, from where we started O, no? OR bar. Okay, sufficient? This is triangle law in vector system. First we learn this in vectors for the addition. OP1 bar means Z1 bar. This is P1 of Z1. This is our position vector. OP1 bar means Z1 plus P1 R bar is nothing but OP2 bar. P1 R bar is nothing but OP2 bar, because that is parallelogram. OP2 bar equals to OR bar. OR bar is Z1 plus, what is OP2? OP2 is Z. Z1 plus Z2 equal to Z. So, this is addition we can represent in the orgone plane, in the plane which is called orgone plane or Z plane as complex plane. Okay. This presentation or the application given by firstly Gauss. Firstly, the mathematician Gauss. Introduced this. What he has given first thought that complex numbers can be represented on a two-dimensional plane, which is therefore called complex plane, Z plane, or orgone plane. In the complex plane, any point in the complex plane, any point other than origin can be represented, and it denotes as a vector, So as a vector property only it will hold. Next. This is You see, let parallelogram OP2 dash or dash P1. OP2 dash R dash P1. OP2 dash R dash P1. Let us complete the parallelogram. This is one parallelogram. This is one parallelogram. OP1 or P2, one parallelogram. So opposite to it, another parallelogram OP2 dash, this or dash P1. This parallelogram OP2, let parallelogram OP2 dash or dash P1 be completed. Then hence OP2 dash plus P2 dash or dash equals how much? OR dash. So this is triangular. OP2 dash plus P2 dash or dash equals how much? OR dash. So we keep like this. OP2 dash bar means minus Z2 because this is parallelogram only, this is Z2. But in this direction change, this is plus Z2, this is minus Z2, plus minus Z2, plus P2 dash or dash, it is nothing but like this now, parallelogram OP1 dash, that is Z1, OP1 bar, that is Z1. This is OR dash bar, Z1 minus Z2. So R bar equals to, OR bar can be taken as R bar equals to Z1 minus Z2. Like this, we can tell the subtraction. The first one is addition. Z equals to Z1 plus Z2. Subtraction. Here, R bar equals to Z1 minus Z2 subtraction. This is R, Z1 plus Z2 by taking parallelogram. This is one parallelogram, opposite to it down, another parallelogram. If we take, and if we apply the vector system according to Gauss, we can explain addition and we can explain geometrical representation of addition and subtraction of a complex number. Now we are going to learn product and quotient of two complex numbers. Geometrically, see the heading. Product and quotient of two complex numbers. Geometrically, how can we get on orthogonal plane? This is a separate application by using similar triangles. Product consideration is, see the figure carefully. I have taken OA, 1 unit OA. I have taken OP1, R1, this length. This is swept angle is theta 1. This is one triangle. OP2 swept angle is like this now. OP2 like this, like this, like this, like this, like this, like this, like this. No, it is swept angle is theta 2. Totally theta 2, theta 2. This is R2. OP2 length is R2. OP2 length is R2. I have constructed another one similar triangle now to this similar triangle. So I have constructed like this. R length is R1 R2 because the product we want to tell. Because these two triangles, this red triangle and black triangle are similar triangles, the angle, internal angle theta 1, the internal angle here also must be theta 1 because these two are constructed such that similar triangles that we are going to construct. Point P1, point A 1, 0, point P1 R1 theta 1. We have learnt in polar system, polar coordinates. So polar coordinates we are using here, polar system we are using here. We are applying polar system. P1 R1 theta 1. R1 is the OP1, theta 1 is the swept angle. OP1 is the ray. This OP1 like this, like this, like this, like this, like this, like this turns. Swept angle is theta 1. And OP1 length is R1. The point is R1 theta 1. Like this in polar system it is represented for the point. So in complex numbers system we are using polar system also. This is connected with vector system only. P2 of Z2. Z2 means R2 comma theta 2. R we have to find it. Construct triangle OP2R similar to triangle OAP1. That what I told now. Similar to OAP1. Construct OP2R. Construct OP2R similar to triangle OAP1. Therefore, triangle OAP1, triangle ORP2 are similar triangles. Therefore, OA by OP2, OA by OP2 equals to OP1 by OR. OP1 by OR. So here, OA by OP2 equals to OP1 by OR. Do cross multiplication. OA OR equals to OP1 OP2. OA we have taken 1 unit. OA we have considered OA 1 unit. So OA is 1 into OR. OP1 O2. OR equals to OP1 OP2 equals to R1 R2. Like this we have given the product on argand plane or complex plane by using polar system connected with vectors. Here also angle AOR. Now this is what R1 R2 OR magnitude, OR modulus. OR modulus we got R1 R2. And the amplitude we have to find this one. Amplitude we have to find for R. Angle AOR theta 2 plus theta 1. Angle AOR, this one. Angle AOR, this one. Angle AOR. What is that? Theta 1 plus theta. Theta 1 plus theta 2. How it is? This is theta 2. This is theta 1. Theta 2 plus theta 1 is angle AOR. Angle AOR, theta 2 plus theta 1. Hence, polar coordinates of R equals to R1 or 2 modulus we got, comma, theta 1 plus theta 2. It is nothing but polar form R1 or 2 into cos of theta 1 plus theta 2 plus I sin of theta 1 plus theta 2 or R1 or 2 cis of theta 1 plus theta 2. That is called Z1 Z2 equals to modulus Z1 Z2 cis amp of Z1 plus amp of Z2. Next quotient. Next quotient consideration. Quotient consideration, please observe in the figure. Here also we are making similar triangles but a small difference. OA I have taken as one unit and OP2 R2 here I have changed for quotient. For according to our convenience to find quotient consideration we have to take like this. So OA 1 unit, that is same. P2 I have taken, P1 I have taken up. So red is up. So here what is this here? This is I have taken OAP2 R2 theta 2 have taken. So this is called R2 and this is called theta 2. And next here OP1 R1 I have taken. OP1 this is totally theta 1. You see, this is totally theta 1. Because this is theta 2, as similar triangles, this internally this part is theta 2. And then angle made by OR with the real axis is how it is? Theta 1 minus theta 2. Then it is called theta 1 minus theta 2. Totally, I want here. What is this? I want this one. I want this one. Because OR angle made by OR with OX. This one. This is theta 2. This is theta 2. Totally this is theta 1. Theta 1 minus theta 2. Then this part will come. Theta 1 minus theta 2. So R amplitude is theta 1 minus theta 2. Now, because of similar triangles, we will find modulus. OA by OR equals to OP2 by OP1. 1 by OR, because OA is 1, equals to OP2 by OP1 means R2 by R1. So OR equals to R1 by R2. Like this, we are going to find the modulus and amplitude of OR. But consideration is different. According to quotient consideration, we have taken like this the figure. But idea is old idea, product idea only. So like this, OR we found R1 by R2. And the amplitude we have found angle OR equals to theta 1 minus theta 2. And OR equals to R1 by R2 comma theta 1 minus theta 2. R equal to Z1 by Z2. That also we know. Hence, R equals to Z1 by Z2 equals to R1 by R2 cis of theta 1 minus theta 2. So, separately we have found OR modulus and separately we found OR amplitude. according to the quotient concentration. This is very important. You have to learn what is OR. OR bar or R equals to R1 by R2 modulus we got by taking similar triangles. Amplitude theta 1 minus theta 2 we got because this OR angle we want. Totally this is theta 1. This is theta 2 and this is theta 2. That's why totally this is theta 1 now. Minus this theta 2. Then what will we getting? This part we will getting. Theta 1 minus theta 2. That is theta 1 minus theta 2. Amplitude. Therefore, the complex number form is R1 by R2 of cis of theta 1 minus theta 2. That is given here. That is given here. It can be told R1 by R2. It can be told R1 by R2 cis of theta 1 minus theta 2. Okay? DEMOIVRE's theorem. DEMOIVRE's theorem. For all n belongs to Q, cos theta plus I sin theta whole power n equals to cos n theta plus I sin n theta. For all n belongs to Z, cos theta plus I sin theta whole power n, cos n theta plus I sin n theta. Similarly, 1 by cos theta plus I sin theta equals to cos theta plus I sin theta whole power minus 1 equals to cos theta minus I sin theta. Because the DEMOIVRE said the index n can be multiplied with amplitude theta. So n theta cos n theta plus I sin n theta. Cos theta plus I sin theta whole power minus 1. Cos of minus theta plus sin of minus theta. Cos of minus theta cos theta. Sin of minus theta minus sin theta. So cos theta minus I sin theta. These three, please try to understand it. This is by mathematical induction, it has been proved by DEMOIVRE. By mathematical induction, it has been proved. But the proof is not necessary for any exam. The result or the theorem result is only necessary for the exams. The theorem result is the index or the power of the binomial should be multiplied with amplitude or argument of the complex number, that may be theta. Observe the fourth point. Cos theta plus I sin theta whole power n. Cos theta plus I sin theta whole power n. Taking binomial expansion. This is just like a plus b whole power n or x plus y whole to the power n. Fourth point, observe. You have learned in lower classes x plus y whole to the power n, x power n plus nc1, x power n minus 1, y power 1 plus nc2, x power n minus 2, y square plus nc3 x power n minus 3 y cube. Like this, the binomial expansion will be there. Even in 10th class also, you have learned it. So, one side binomial expansion, another side DEMOIVRES. What is the DEMOIVRES? Cos n theta plus I sin n theta. And then please compare and equate real and imaginary parts. Real and imaginary parts. The real part is cos n theta and the imaginary part is sin n theta. In the binomial expansion, the real part you take and the imaginary part also you separate and you compare the real part equals to cos n theta. That cos n theta real part in the binomial part, in the binomial expansion part, cos n theta equals to cos n theta equals to cos to the power n theta minus nc2 cos power n minus 2 theta sin square theta plus nc4 cos to the power n minus 4 theta sin power 4 theta minus next nc6 cos power n minus 6 theta into sin power 6 theta. And observe here, all even numbers will be coming. NC2, NC4, NC6, NC8 will be coming. And first term for cos n theta equals to cos to the power n theta. Next term with minus. So next term with plus. Next term with minus. So alternatively the terms signs are changing. And all we are taking even numbers. This should be observed by you. Cos n theta equals to cos to the power n theta minus nc2 cos to the power n minus 2 theta sin square theta plus nc4 cos to the power n minus 4 theta sin power 4 theta minus so on, like that. Next, sin n theta imaginary part, if you compare both sides, nc1, if you understand the cos n theta sin n theta, you can easily understand. nc1 cos to the power n minus 1 theta sin theta minus nc3 cos to the power n minus 3 theta sin cube theta plus nc5 cos to the power n minus 5 theta sin power 5 theta minus so on. So here also alternatively plus minus will be coming. But NC1, NC3, NC5, NC7, NC9 will be coming. In cos n theta expansion, NC0, NC2, NC4, NC6, NC8, NC10, so on will be coming. That should be observed by you. For tan n theta equals to NC1 tan theta minus NC3 tan cube theta plus NC5 tan power 5 theta. Like this, all alternative signs will be changing, but 1, 3, 5 will be coming, and denominator is 1 minus NC2 tan square theta plus NC4 tan power 4 theta minus NC6 tan power 6 theta plus so on, alternative signs, and 1 minus, it will be beginning with 1 minus, and NC2 2, 4, 6 even numbers will be coming, and alternative signs are there. Signs alternatively changing. This property you have to observe. Totally tan n theta equals to nc1 tan theta minus nc3 tan cube theta plus nc5 tan power 5 theta minus so on whole by 1 minus nc2 tan square theta plus nc4 tan power 4 theta minus nc6 tan power 6 theta plus so on. Please observe cube roots of unity, cube roots of unity, cube roots of unity. Let z equals to 1 by 3, then z cube equals to 1, or z cube minus 1 equals to 0, or z minus 1 into z square plus z plus 1 equal to 0, implies z equals to 1 or z equals to, by applying minus b plus or minus root over b square minus 4ac by 2a, with that formula we got z equals to minus 1 plus or minus I root 3 by 2. Therefore, cube roots of unity are 1 comma minus 1 plus I root 3 by 2 minus 1 minus I root 3 by 2. This is very important. 1 comma 1 is real number, and minus 1 plus I root 3 by 2 minus 1 minus I root 3 by 2, both are complex numbers. These two complex numbers have one relation, the very good relation will be there. If you take minus 1 plus I root 3 by 2 and square it, you will get minus 1 minus I root 3 by 2. If you take minus 1 minus I root 3 by 2 and square it, you will get minus 1 plus I root 3 by 2. This is a good relation between two complex roots. Properties observe. Each complex cube root of unity is the square of the other. That's what I told. Therefore, let roots, one real root, one root is omega minus 1 plus I root 3 by 2. Another root, we can take it as omega square granted, because just I told omega square minus 1 plus I root 3 by 2. If you square it, you will get minus 1 minus I root 3 by 2. If you take minus 1 minus I root 3 by 2 and square it, you will get minus 1 plus I root 3 by 2. So you can take this one omega square, or this one omega square, or omega. But we are taking now minus 1 plus I root 3 by 2 as omega. Now, third property is 1 plus omega square equals to 0. How it comes? By itself only we can understand. 1 we keep as it is, plus omega we keep minus 1 by 2 plus I root 3 by 2. Omega square we can keep minus 1 by 2 minus I root 3 by 2. All get cancelled, you will get 0. Fourth property, 1 into omega square equals to 1. Like that only you have to find the product. If you find the product, you will get the 1. Next, as 1 into omega square equals to 1, what will be omega? Naturally 1 by omega square. Or omega square will be 1 by omega. Because 1 omega square equals to 1, omega equals to 1 by omega square, or omega square will be 1 by omega. Next, if n is positive integer, 1 plus omega power n plus omega power 2n equals to 1 plus omega power n plus omega power 2n equals to 3 when n is the multiple of 3. When n is multiple of 3, the answer will be 3. When n is not a multiple of 3, the answer will be 0. So, 1 plus omega power n plus omega power 2n, 1 plus omega power n plus omega power 2n equals to 3 and 0. Both answers will be there. When n is multiple of 3, it will be 3. When n is not a multiple of 3, the answer will be 0. Next. Cube roots of unity represent vertices of equilateral triangle in the organed plane. Cube roots of unity (1 omega square) represent vertices of equilateral triangle on organed plane. See the figure. See how it is. This is x-axis. We don't say x-axis. It is a real axis. We don't say y-axis. It is imaginary axis. So, 0 to 1. So, on the circle, 1 will be there. Omega will be there. Omega square will be there. Omega means minus 1 plus I root 3 by 2. Omega square means minus 1 minus I root 3 by 2. These 3 points on the circle as such making an equilateral triangle. Cube roots of unity represent vertices of equilateral triangle on organed plane. We can prove it. The proof is for intermediate, but for the competitive examinations, the result is very important as far as you remember. Some applications just for your understanding it was given. If n is a positive integer, then 1 plus cos theta plus I sin theta whole power n plus 1 plus cos theta minus I sin theta whole power n equals to 2 to the power n plus 1 cos to the power n theta by 2 into cos n theta by 2. 1 plus cos theta plus I sin theta whole power n. We have to write 1 plus cos theta as 2 cos square theta by 2. I sin theta can be written as 2 sin theta by 2 cos theta by 2. Here 1 plus cos theta we can write as 2 cos square theta by 2. Here I sin theta 2 sin theta by 2 cos theta by 2. Just we have taken. And we can take common as 2 power n cos power n theta by 2. Because always power n is there. Power n is there. So from power n, if we take this part 2 power n cos power n theta by 2, take out common from power n, we can write like this 2 power n cos power n theta by 2, big bracket, flower bracket begin, cos theta by 2 plus I sin theta by 2 whole power n plus cos theta by 2 minus I sin theta by 2 whole power n. So here equals to 2 power n cos power n theta by 2. According to DEMOIVRE, cos theta plus I sin theta by 2 whole power n can be written as cos n theta by 2 plus I sin n theta by 2 plus cos n theta by 2 minus I sin n theta by 2. What Demoivre said? The index or the power n can be multiplied with amplitude or argument theta by 2. So cos n theta by 2 minus I sin n theta by 2 minus I sin n theta by 2 plus I sin n theta by 2 get cancelled. Cos n theta by 2, cos n theta by 2, 2 cos n theta by 2. Another 2 power n is there. 2 power n into 2 power 1. 2 power n plus 1 cos to the power n theta by 2 into cos n theta by 2. See here, the second model application for omega application. For the omega application, it was given a plus b omega plus c omega squared by b plus c omega plus a omega squared plus a plus b omega plus c omega squared by c plus a omega plus b omega squared is always minus 1. Just we have taken omega in the numerator. I have taken omega in the numerator. Omega into b omega. Observe numerator. Omega into c omega square. Observe it. A omega square into omega, a omega cube. A omega cube. Omega cube equals to 1. So a only remains. A plus b omega plus c omega square can be written as omega of b plus c omega plus a omega square. Whole by denominator we don't change b plus c omega plus a omega square because why we don't change? Because we have changed the numerator in the form of the denominator. So denominator get cancelled. Denominator and the numerator get cancelled. Omega will remain. Similar case, omega square I have take common. Omega square into c omega square. Observe the question. Omega square into a omega cube into a. Omega cube is 1. So a remains. Observe the before step. And b omega power 4. B omega power 4 means b omega cube into omega. Omega cube is 1 b omega. So b omega is there. Please observe the fourth step. So if you take common omega square, c plus a omega plus b omega square in numerator, below the same denominator will be there. Get cancelled. Omega square will be left. So omega plus omega square equals to minus 1 because you have learned the property 1 plus omega square equals to 0. 1 plus omega square equal to 0. You have learned the property 1 plus omega square equal to 0. Therefore, omega plus omega square equal to minus 1. That is our answer. That answer is, for this question, we get this answer. Minus 1 is the answer. Next, come to the nth root of unity. The nth root of unity. X equals to 1 to the power 1 by n. X power n equals to 1. Nth root of unity means 1 to the power 1 by n. That can be taken as 1 to the power 1 by n can be taken as nth root of unity. That is let it be x. Both sides raise the power n. X power n equals to 1. 1 can be written in the complex number form. 1 plus a into 0. 1 plus I into 0. 1 can be written as 1 plus I into 0. Cos 0 plus I sin 0. That is in the polar form. That polar form, cos 0 plus I sin 0 is the polar form, a particular polar form. But you have to write the general polar form. For general polar form, you have to add 2k pi to the amplitude angle. 2k pi plus 0, cos of 2k pi plus 0 plus I sin of 2k pi plus 0, where k belongs to z. Again listen, cos 0 plus I sin 0 is the polar form for 1. But it is that cos 0 plus I sin 0 is a particular polar form. But we want to change it general polar form. For general polar form, you have to add 2k pi to any amplitude. For any question, cos theta plus I sin theta, if it is given 2k pi plus theta, that is general polar form. Cos theta plus I sin theta is a particular polar form. So you have to use 2k pi, always 2k pi only. Need not change. Cos 2k pi plus theta, cos 2k pi plus 0 plus I sin 2k pi plus 0. What is k? That you should mention where k belongs to z. According to DEMOIVRE, x power, what is x? X is, what is x? X is 1 to the power n 1 by n. What is x here? X is cos 2k pi by n plus I sin 2k pi by n. So x power 1 by n, it is x 2k pi by n plus I sin 2k pi by n. Because what is x? X is 1 to the power, x is 1 to the power 1 by n. What is here x? What is this? Cos 2k pi plus I sin 2k pi where k belongs to z. This is cos 2k pi plus I sin 2k pi is x power n. Please observe. Please observe. What is x power n? Final step. Second step 1 plus I 0. Third step cos 0 plus I sin 0. Fourth step general polar form cos 2k pi plus I sin 2k pi x power n. What is x? You have to use 1 by n. By 1 by n you have to rise, then x power n will be x. If you rise right side also by 1 by n, and then according to DEMOIVRE, amplitude into the power cos 2k pi by n plus I sin 2k pi by n, according to DEMOIVRE. Let alpha equals to cis 2 pi by n. And then what will be? Then nth roots of unity can be written as alpha is cis 2 pi by n. Please observe, x equals to cos 2k pi by n. Cis 2 pi by n means k will be there. So 1 comma alpha means cis 2 pi by n. Like that only, no? Alpha square means cis 4 pi by n. Like that only, no? According to DEMOIVRE. So if you take alpha cis 2 pi by n, you can write this cis 2k pi by n. If you take alpha cis 2 pi by n, you can write this as 1 comma alpha square comma alpha cube so on up to alpha power n minus 1. These roots are called nth roots of unity. 1 alpha square, alpha cube, so on, alpha power n minus 1, where alpha is cis 2 pi by n, where alpha is cis 2 pi by n, where alpha is cis 2 pi by n. And now, sum of the roots sum of the nth roots of unity. 1 plus alpha square plus alpha power n minus 1. This is sum of the GP series. Sum of the GP series only. That is why 1 plus alpha square plus alpha power n minus 1, sum of the GP series can be written as 1 minus alpha power n by 1 minus alpha. What is alpha power n? Alpha power n since cis 2 pi by n whole power n cis 2 pi. Because alpha is cis 2 pi by n. I have told you, alpha is cis 2 pi by n. That is why here alpha power n equals to cis 2 pi by n whole power n cis 2 pi. Cis 2 pi means how much? Cos 2 pi 1 plus I sin 2 pi I into 0. Cos 2 pi plus I sin 2 pi. Sin 2 pi is 0. Cos 2 pi is 1. Therefore, cis 2 pi equals to 1. Therefore, 1 plus alpha square plus alpha power n minus 1, sum of the roots, sum of the nth roots of unity, 1 plus alpha square plus so on, plus alpha power n minus 1 equals to how much? 1. Product of the roots, 1 into alpha square into alpha cube so on, alpha power n minus 1 will be coming. So this can be written as, how it is? Alpha to the power 1 plus 2 plus 3 plus so on plus n minus 1. Alpha to the power 1 plus 2 plus 3 plus so on plus n minus 1. So what is natural numbers? Sum of the natural, first sum of the unnatural numbers, 1 plus 2 plus 3 plus so on up to n minus 1 is n into n minus 1 by 2. Alpha to the power n into product of the roots, 1 into alpha and alpha square, alpha cube, so on. Alpha power n minus 1 equals alpha to the power n into n minus 1 by 2. What is alpha? Cis 2 pi by n. I told you alpha is cis 2 pi by n. Alpha is cis 2 pi by n. Alpha is cis 2 pi by n. So here, what is that? Cis 2 pi by n to the power like this. So, according to DEMOIVRE, cis 2 pi by n into n minus 1 by 2, amplitude and power should be multiplied. 2 to cancel, n cancel, pi into n minus 1. So, cos pi plus I sin pi to the power n minus 1 we can write according to DEMOIVRE. What is cos pi? Minus 1, sin pi 0. Cos pi plus I sin pi is minus 1. Minus 1 to the power n minus 1. It will be minus 1 if n is even, and it will be plus 1 if n is odd. If n is odd, it will be plus 1. If n is even, it will be minus 1 of minus 1 to the power n minus 1. This is up to nth roots of unity. Sum of the nth roots of unity is how much? Sum of the nth roots of unity is 0. Sum of the nth roots of unity is 0. Product of nth roots of unity is minus 1 to the power n minus 1. This is very important result. You have to remember the product of the nth roots of unity will be minus 1 to the power n minus 1. If n is even, it is minus 1. If n is odd, it is plus 1. Product will be like that. This is different. Okay, let us meet in another class. Hi. I hope you have gone through my video, today's video, and you have learned something about DEMOIVRE's theorem, nth roots of unity, cube roots of unity, geometrical representation by Gauss. All these things you have gone through it. I hope so. For better videos, for regular better updated videos, please like, share and subscribe my videos so that you will get my videos updated. Up to 2021 MSET, Intermediate, MSET, JEE Mains and JEE Advanced exams. Till then, I will go on giving videos. All people, all kinds of students, they can learn the subject. Okay. Next, first I start the foundation of the subject, and next coming to intermediate level. So for intermediate students it will be useful. To the next level, for the MSET level subject you will learn. For the people, for the aspirants of MSET also, they can prepare this video. They can follow this video. And in the next level, JEE Mains, and I will discuss JEE Mains previous 10 years questions and how the questions, models, the types of questions on this topic will be appearing in the question papers. And for advanced also, how the mixed questions will be given, that also I will definitely I will discuss. So on one topic, intermediate, MSET, JEE Mains, advanced, in these layers, in the layers going to be higher, I will give you my videos on one topic, at least 5 to 6 videos. Like this, I will continue, go on making videos till 2021 exams. Please follow, tell your friends, pass on this news to all of your friends, mostly to government college students who are, some students are poor. They will be benefited by watching my videos, at least at home or somewhere. You can watch my videos anywhere. And some students are not able to go to colleges. They are doing some jobs. They also can prepare for intermediate or MSET or JEE Mains with the help of my videos. Please pass on to all kinds of students. My dear students, please pass on to all sorts of students so that they will be benefited, they will be flourishing, they will be growing in their lives. For that, again I am telling, don't forget to like, share and subscribe. Okay, thank you very much.